Swayam Prabha. Digital India. Educated India.
Hello, good afternoon. So, welcome to the course on comprehensive view of speech processing. So, today's lecture is 37 in series, and today we are going to discuss one more important the speech task, that is automatic speech recognition. And in the last class we discussed about speech coding. So, this was the speech coding is the application that is very popular and demanding during 70s, 60s time. So, that time the only speech application that is very much in demand is the speech coding, or basically the speech application or the speech that is used in the telephonic applications, basically speech transmission through like a telephone channels, basically telephone applications, the speech conversation through telephonic channels. So, that is the main application during that time 60s, 70s. So, during that time, as the memory is also very expensive, and also the channel bandwidth is also very expensive, and to cater the channels or this speech transmission across the globe for multiple customers. So, the utilization of bandwidth is a very primary issue, prime issue, and as well the storage also. So, in view of that, during that time the speech coding application has been very much in demand, and so that way in last class we discussed about various types of coding schemes, and when you are developing a speech coder, so what are its objectives, right. Basically, when you develop a speech coder means then the coded speech, what are the requirements of coded speech in the form of qualitative perspective, and what are the various objective and subjective measures for evaluation of a coded speech. So, all these things we have discussed, and we started from the discussion on developing the speech coders by exploiting the time domain characteristics of a speech, then the frequency domain characteristics of a speech, and then the perceptual characteristics or like auditory characteristics of a speech, and speech production knowledge, exploiting that. So, all these aspects we have discussed, and we studied about the various categories, various types of speech coders, basically mainly focused on analysis by synthesis coders, which are based on the linear prediction analysis. So, in that we discussed about a KELP coder, then the low bit rate coders such as MELP, and the different types of MELP coders, and finally how the speech coding or how the speech transmission will be carried out over internet. And in that case, suppose if during the transmission of packets through internet, if some voice packets are lost, so in that case in view of realistic application, how do we take care of it? So, all those issues we have discussed, and today we are going to discuss about the ASR or like applications known to be automatic speech recognition application, and all of you are very familiar with this speech task. This ASR, automatic speech recognition, is very well known and very important the speech task. It can be used in several applications, and most of us are familiar with this in most of our day to day life. And basically suppose we want to develop a speech interface for a machines, then one of the tasks that need to be carried out will be like ASR, that is automatic speech recognition. That means here basically the ASR task, the objective of ASR or automatic speech recognition is nothing but from the speech signal. So, we need to derive the text. So, it is nothing but the sequence of words. That means whatever we speak, like whatever the human speaks, and from that speech signal, so we need to automatically derive the text that is present in that particular speech signal and all. So, the text is nothing but sequence of words. So, this transformation of speech to text is nothing but can be viewed as the speech understanding from a machine perspective. Whereas from human perspective, suppose when I am speaking and here the students here can able to hear my voice, they can able to understand, and if required they used to respond also. So, from a human perspective, like the speech understanding is nothing but from a speech signal the target person or the target human, whether he can able to get the message out of it or not. So, if you can able to like infer the message from the speech signal, it is known to be like speech understanding from a human perspective. Whereas, from a machine perspective, the receiving a message is nothing but from a machine perspective, it is nothing but if a machine can able to like derive the text from the given speech signal. So, it is known to be like it is known to be machine from a machine perspective, it is known to be speech understanding. And because a machine, because as a human we do not know like what is the message, but by perceiving that we can able to understand what the underlying message is that. But from a machine point of view, it should be in a deterministic way. So, therefore, we need to derive the text. So, the text can be viewed as the message that is derived from the speech. So, how do we do that? How do we do it? So, and here before going to this, I want to just mention the generic block diagram or a generic sequence of stages that are present in a speech recognition in a generic framework. So, here we have a speech signal, the ultimate input output will be like given input is a speech signal and the output will be the text, it is nothing but sequence of words. And here the speech signal means it is nothing but the acoustic pressure variations, that means the signal that is the speech signal when you are speaking, the speech is produced as the acoustic pressure variations, and that signal will be captured by the microphone, and the microphone captured signal will be again for storing purpose or for representing the purpose, that will be again stored, again it will be converted to digital, and the digital form the speech is stored in the form of bits, sequence of bits. So, here that particular speech signal whatever is captured from the mic, that is the input, and the outcome is the text. And for doing that, for performing that, different stages that are involved over here will be at a gross level. We can view the process of converting speech to text can be carried out by 3 different stages or 3 different modules. The first one is known to be the feature extraction. It means that from a speech signal, like it is nothing but the acoustic pressure variations or the electrical signal whatever is captured through a microphone. From that we need to derive a relevant features which characterizes the sound units, because the speech is nothing but contains the message, it is nothing but words, and the words are nothing but at a lower level the words constitutes a sounds, a sequence of sounds, right. Any word can be splitted into sequence of sounds. So, that way for deriving the sounds here, first of all from the speech signal we need to derive the features which those features basically discriminate or characterize the sound units, because as we know that the speech signal carries the multiple types of information. So, one of them is the sound specific information, along with that it also carries the other information such as the speaker specific information and and also the language linguistic information, and it also contains the background environment and emotional information and paralinguistic information. Likewise, lot of different types of information that are present in a speech. So, here for the task of speech recognition, automatic speech recognition, so the feature extraction module are where from which we have to derive the feature vectors which basically characterize the sound units, So, that way the feature vectors are derived from a speech signal. So, how do we derive the feature vectors? So, we have seen like in the previous lectures we have seen. So, we can able to compute the feature vectors from the speech signal by taking the frames, and we apply the transform will convert into frequency domain, that is by applying fast Fourier transform we will get the Fourier transform, and from the Fourier transform we can able to derive the spectral vectors directly, or otherwise by performing the LP analysis you can get the linear prediction coefficients corresponds to each frame, and again from the spectral vectors you can also derive the Kepstrom, and from the Kepstrom you can able to derive the Kepstral vectors. Likewise, different ways you can able to extract the feature vectors, and all these the requirement and all these feature vectors basically try to highlight or try to characterize the sound units. So, that way the feature vectors are derived from the speech signal, and using those feature vectors we need to build a model. We need to build a model that depends upon the task, So, suppose for example, if you want to perform a speech recognition, and here the end to end task is that speech signal and here the text, but here there is a intermediate module known to be the acoustic model. So, this acoustic model basically derives the sound units from the feature vectors, So, therefore, here this acoustic model is nothing but it is a kind of a classification system that we discussed in the previous lectures, right. It is a kind of a classification system where that depending upon the number of sound units that need to be recognized. So, that many number of classes are present in this particular acoustic model, right. So, suppose for example, if you want to perform the sound unit that is characterized or that need to be recognized is the phoneme, right. So, in that case we know that in any language the number of phones will be around 40 to 50. So, accordingly this acoustic model is nothing but here we need to develop an acoustic model or nothing but a classification model or classification system that used to classify the feature vectors across these 40 or 50 classes, 40 or 50 phoneme classes and all. So, that way this acoustic model will be built, and we have seen that how to build the acoustic model. For example, we had taken a very naive example of a 2-class classification system, deriving a 2-class classification system where those 2 classes are corresponds to handwritten characters of A and B, right. So, suppose we have A and B we have written with a hand, like they are handwritten characters, and they have taken their image, and that image has been given as input, and from that we need to output, or the classification system has to decide classify that the input image corresponds to either A or B. Likewise, here in the case of speech recognition system, if the output is a sound unit or a phoneme, so in that case from the given feature vectors or the sequence of feature vectors, so we need to decide or we need to classify the set of feature vectors corresponds to which of the phoneme, that means we know that there are about 40 to 50 phonemes, and here we need to categorize or classify that which of the phoneme this particular the corresponding set of feature vectors corresponds to. And this acoustic model can be realized by using either the Gaussian mixture models, right. We have studied about that, how to build the Gaussian mixture model, and then similar to that you can also build the using hidden Markov models also, because the hidden Markov model Gaussian mixture models they try to capture the distribution or the probability density function related to the set of feature vectors, and whereas the hidden Markov models so they try to capture the sequential knowledge across the feature vectors is also captured along with the distribution and all. So, that way in case of hidden Markov model, where each sound unit can be represented as like a 4-state model or a 3-state model or a 5-state model, that depending upon the sound unit or the actual number of vocal tract shapes that involves in production of the particular sound unit. So, that many states can be realized. So, that way you can use the hidden Markov model for modeling each of the sound unit. Suppose there are 40 phonemes, means we need to build 40 HMMs where each HMM corresponds to a specific sound unit, and then the set of feature vectors will be given to all the HMMs, all the 40 hidden Markov models corresponds to each of the phoneme, and from that whichever the model gives you the higher the probability of O given the model. So, higher probability that will be hypothesized as the sound unit. So, that way this acoustic model basically takes the input as sequence of feature vectors, and output will be the label associated to the sound unit. It is nothing but, or can also known to be symbol and all. So, it means that from the sequence of feature vectors to it converts to symbols, right. And then here they are the sequence of phones or the sequence of the sound units and all. from the sequence of sound units by using the language model. Suppose we know that these sequence of sound units are corresponds to language Hindi, or this corresponds to language English. Suppose we know that a priori we know that the speech corresponds to whichever the language, if you have an idea about that, then the corresponding language model will be used. Here what is meant by language model, that we will discuss in detail later, but here the language model is nothing but it used to provide the constraints or indicating the constraints related to the sequences of sound units. Because as we have mentioned in the very beginning in introductory class of speech processing itself, the language model is nothing but it tries to informs you that we have a 40 phones are there, right, and these sequence of phonemes that provides you that that defines the words, right. But in the when you are providing the sequence of these sound units, it is not only some legal sequences are eligible for forming the legal words, right. Only from legal sequences of the phonemes that forms the words. Otherwise, there are 40 sound units are there. So, therefore, if you try to try to find out, make out the number of possible words with a sequence of 10 phonemes together, there are like a huge number of words that are possible, but all those words are not legal, are not corresponds to a language and all. So, therefore, each language it tries to provide some constraints. It means that which of the phone sequences that are legal for a given language, that those are qualified for a word. So, that way if you take a language, if you see the English language for example, dictionary and all, you can see that how many words are there present in an English dictionary. There may be lakhs, in terms of some lakhs of words that are existing. Beyond that, only those words are permissible for a English language. So, therefore, here these phone sequences will be validated by using language model, and based on that the language model will provide you the output of the what are the most probable words from this given sequence of sounds, because from the language model we will come to know that what are the from a given sequence of sounds, what is the most probable word from the given sequence of sounds. So, that way we will try to estimate the words from the given sequence of sounds, and once the words are there, then again from the words also we have the further in this language model we have different stages used to be there. At the first stage, from the given sequence of sounds we will try to validate and tries to give the words, and then there is a next level language model where it tries to validate the sequence of words. Again, in the words also, it is not that any word sequence will not form the meaningful phrase or meaningful sentence and all. So, that way the language model itself there are multiple stages. So, where each stage will tries to perform validate at the initial stage it tries to validate the sequence of sounds, and then it gives you the words, and the sequence of words are validated by next stage. So, then finally you have the message that is corresponds to the given speech signal. So, this way the conventional the speech recognition engine will perform the task of converting speech signal to the given text. And so, here in this case, if you look at here, this particular speech recognition framework that involves a feature recognition as a separate module, and then acoustic model as a separate module where it converts the features to appropriate sequence of sounds, and then the language model where it takes the input as a sequence of sounds and provides the word sequences or the text. So, that way there are different modules are involved. Each module has some control parameters, and if you try to maximize the performance of each of them. So, therefore, when you try to maximize here, and then afterwards when you tries to maximize that, and here the parameters whatever here that may not be optimal here. So, likewise here in the case of modular based speech recognition system, there are several modules used to be there, and each module has certain optimal criteria, optimal parameters used to be there. It is not that the optimal parameters of this may not be suitable for optimizing this one, and the optimal parameters of this may not be suitable for optimizing this one. So, that way to overcome this, in the recent past, in the recent decade, we have a speech recognition framework which consists of like end-to-end framework. It means that we are not bothered about these individual modules and all. Like we will take the input from a speech, that means the speech has been given as input, and directly the output will be the text. There is nothing but sequence of words or sequence of alphabets, whatever. And all these modules, they will be put integrated together, and we will try to optimize the overall system together instead of optimizing the module by module and all, right. So, that is known to be end to end framework, and now with the advent of the availability of the deep architectures and availability of huge amount of data, they have end to end the speech recognition systems are available. So, in that case we need not bother about the better feature extraction modules and the best acoustic model and language models, all these the individual modules are not required and all. So, provided we need to have a deep architectures are required, and then huge amount of data is required, and for performing or for training the system or for building the system. So, we need to have huge computational power and other resources are required and all. If we have that, then it is better to go for end to end framework of speech recognition system. But here in this particular class, we will try to focus on this conventional module by module framework of speech recognition. And then coming to here, the formulation for a speech recognition, as I mentioned here, it is converts the speech signal to the text, that is the basic objective, and for that we can view this the transformation of speech signal to the text can be viewed as a classification problem, as I mentioned over here, right. So, here you can able to mention as the output is a word sequence. So, here the objective can be realized by using this expression. You can say W star is nothing but the optimal word sequence, and this optimal word sequence is, for that we need to find out these posterior probabilities, that is P of W given Y, where W is nothing but the word sequence. It means that we will try to find out the probability of the word sequence given the observation sequence. That means we will take we know the observation sequence, and then we will try to validate, we will try to compute the probability of the word of each word sequence from this given for the given observation sequence. This is known to be the posterior probability. It is known to be a posterior probability. It means that what is the probability of a particular word sequence from this given observation sequence, given the observation sequence. So, that way we will try to validate, we will try to find out the posterior probabilities of various word sequences. Out of that, the maximum is determined, and that maximal probability, whatever the word sequence that contains the maximal probability. So, that word sequence will be viewed as a W star. It is known to be optimal word sequence. So, this is the standard classification framework that we have seen when you are discussing about the Bayes theorem, right. So, W is the word sequence, W is the observation sequence, and in this context it is nothing but sequence of feature vectors. So, this is the formulation. Probability of W given Y, it is known to be posterior probability with respect to a specific word sequence. So, we will try to find out the posterior probability for all possible word sequences, and out of that whichever is the maximum probability. So, that will be considered as the hypothesized as the word sequence for the given speech signal. So, for performing or for computing this probability, that is a posterior probability, that is the probability of the word sequence given the observation sequence, we will do it indirectly this way by using this formulation. This is nothing but a Bayes theorem, like probability of W given Y is nothing but probability of the observation sequence given the word sequence into the probability of word sequence divided by probability of Y. And since the denominator is the normalization factor, that means it will be present for all the posterior probabilities. So, therefore, we need not really compute, or we need not really bother about the denominator and all, because the same denominator is present for all the posterior probabilities. So, we need to find out the maximum among these. So, therefore, we do not bother really about the denominator, right. So, we need to find out, we can find out the probability of W given Y, probability of the word sequence given the observation sequence in this way, probability of Y given W into P of W. But what is the probability of Y given W? Probability of Y given W is nothing but the likelihood function. It is nothing but we are trying to find out the probability density of the set of observations from the given word model, right. So, it is nothing but PDF of a specific word model, right, and then P of W is nothing but language model, it is nothing but prior probability. It is nothing but here without knowing the observation what will be the probability, what is the probability of a given word sequence. It is nothing but by observing the statistical history, if you have like all word sequences are possible, from that we can able to find out the P of W, right. So, that way this is known to be prior probability, that means without observing the data itself, can you estimate or can you find out, can you give the probability of the word sequence. So, based on this framework you can able to compute this, and from that maximization of that gives you the word sequence. So, that way you can able to like find out the optimal word sequence from the given set of feature vectors. So, this is the standard the classification framework what we have discussed. Then coming to the depending upon the task, the ASR can be viewed or can be categorized into 3 different types at a gross level. So, one is known to be the isolated word recognition, and the other one is known to be a connected word recognition, and the third one is the continuous speech recognition. So, we will discuss each of them one by one. We will try to, when you are discussing here, means we will try to see that what is meant by isolated word recognition, right, and in that what are the issues in that, right. So, isolated word recognition means here the task is that, so that means the input for this particular one, the input will be only one word it contains, that means the speech signal contains a single word, and we need to determine that word, we need to determine the text corresponds to that particular word. It is known to be isolated word recognition. This is a kind of this system is used in kind of command control systems, where suppose if we want to like operate the robot for example. So, where if you want to give instructions to the robot, so where you can able to indicate or you can able to like indicate the instructions to the robot using a voice interface, using words, different words like start, it means the robot will start, forward, move forward, like backward, or like raise the hand. So, likewise you can able to give a simple words like only one word mostly. So, then it is known to be like here the task is that robots should understand what you are speaking, and from that accordingly it takes it performs the action and all. So, that way not only that, in case of for example in home appliances, for example if you want to control the home appliances using the speech mode for example, you can use this word isolated word recognition system and all, isolated word recognition system. Or otherwise sometimes you can see that in the voice interface systems where they will ask you about like they will play different questions and you need to answer whether it is yes or no, or otherwise we had to tell about like which among the choices you are preferring. So, in that case only one word is expected from the target, and that word has to be recognized by the machine and all. So, that way in case of isolated word recognition, the task is that the speech signal contains only one word and you need to identify that particular word. And here it appears to be simple because only one word is there, and your entire task is to just to detect or determine what that word is, what the text corresponds to that particular word. And for that here the issues are here first one is that actually we have a speech signal, in that the word is present. So, first of all to determine that word, to determine the text corresponds to that, we need to extract the features from that particular word and then use those features, and you have to determine which word is these features corresponds to. And for that first of all we need to detect the location of the word in the signal, the location of the word in the signal. So, the first issue here is that endpoint detection, that means begin end detection. It means that you have spoken a word at some point of a time, but it is a signal, it is a continuous signal, and you need to find out where the word begins and where the word ends. And by knowing these 2 points, then afterwards you need to extract the features between those 2 points from the signal that corresponds to between those 2 points. So, that way the endpoint detection is nothing but detecting the word boundaries is the primary issue, one of them. And another thing here is that in this case the number of words that are present in this particular task will be huge, a reasonably large number, it is in terms of maybe hundreds to it may go up to the thousands. So, that many words are used in the system where the system can able to recognize or discriminate those words. And basically for this purpose we use the template matching. It means that here the recognition step is nothing but we will perform by using template matching, and with that you can able to do it. Because here we know that the target application is meant for recognizing the words. So, therefore, the duration of the words are like more or less of some specific duration. So, therefore, here the idea here is that template matching is nothing but by using some training data, some known samples, we will extract the sequence of feature vectors corresponds to each word, and then when you are testing, so whatever the test utterance is there, from the test utterance we will extract the feature vectors, we will try to match the feature vector by feature vector with the reference template, with the reference feature vector. And so, that is known to be template matching. We will see that what is meant by template matching and all. And here when you are performing this template matching, the issue will be time alignment, because when you are speaking a word, for example, when you say fan for example, and when I uttered fan and when somebody uttered fan, so the duration of the word is not same. The duration of the word will vary from speaker to speaker, and within the speaker also, when you speak word fan now and when you speak fan somewhat later time, there is some variation in the duration. So, that way when you extract the feature vectors, the number of feature vectors they are different, right. So, therefore, here maybe in the case of reference template or the you can say that in the trained model, the number of feature vectors corresponds to a word may be 20, but when you are uttered the word, so it may contains only 16 feature vectors, or it may contain some 27 feature vectors, right. So, how to match these time varied the speech signals and all. So, that way here we will make use of for time alignment, we use the different techniques. One of them is the dynamic time warping approach. We will see that how by using dynamic time warping we will perform the matching between the reference word to the test word. And here another thing, there is no contextual information. It means that the task itself is isolated word recognition, that means only one word will be uttered. So, therefore, there is no contextual information, only one word will be there, that word will be one among those 1000 words, whatever it may be, any word is possible, right. So, therefore, there is no contextual information, that is no grammar, no syntax, right. So, that way it is a difficult, because all words are equally probable, for example, they are equally important. So, in that case all are equally probable. So, therefore, we can't guess which word is the more probable and all. So, therefore, all words are equally important. So, that is a very difficult in taking a decision and all. And another important thing here is that since here the isolated word recognition, it means that the person is uttering a word. So, therefore, and the word means it consists of sequence of sound units. So, because of that, the co-articulation knowledge, or that means the co-articulation characteristics that are embedded in the word. So, that way if you look at the word level features or the word level characteristics that are uttered by different speakers or across the within the same speaker also, the variability is slightly less. There exists a variability, but the variability will be less, because whatever the word you are uttering, the same word is uttered by some other speaker. So, either you utter the word or somebody else also uttered the word. For uttering the word, you have to utter the same sequence of sounds. So, if you want to utter the same sequence of sounds, the vocal tract shape will also follow the same sequence of shapes it follows to utter or to produce the specific word. So, that way the variability is less, right. And then another one, as I already mentioned, all words are equally important, right. All words are, because we have to utter only one word, and that depending upon your requirement you are uttering the word. So, therefore, there is no initial presumption that so which word you will be speaking. So, no idea about that. So, all words are equally important. So, that way these are various issues or various constraints that are involved in the isolated word recognition. It appears to be like a simple task, but it is not that easy, right, because first of all the beginning detection is a task, and afterward there are about thousands of words, right, and we have to discriminate all of them, right, and so like, and again the words are of different lengths used to be there. So, therefore, the time alignment is required, and no contextual information. So, all these are the various issues that are involved in the isolated word recognition. And examples to these are digit recognition. Suppose if you want to dial a telephone number, for example. So, using isolated word recognition also you can able to perform, right. So, it means that you can able to just utter the digits one after another by giving a pauses. So, that you can, by using isolated word recognition, you can able to carry out the task of phone dialing and so on. And not only that, some proper nouns, for example, if you want to recognize the words of the names, so in that case also, if the entire name consists of only one word, so you can use the isolated word recognition for recognizing the names of the towns, or names of the people, or names of the different places, assuming that the entire all of them consist of only one word. And the next task is the connected word recognition. And here in the connected word recognition, so here the vocabulary is relatively small compared to isolated word recognition. The vocabulary is relatively small compared to isolated word recognition. It means approximately it may be 20 or 30 words used to be there, but connected word means here the utterance or the speech that need to be recognized contains a sequence of words, right. It is not single word. If it is a single word, it is isolated word recognition, and here the task is that from a speech signal you need to detect a sequence of words, right. So, so that way it is a connected word recognition. So, by using connected word recognition, we can use this task for performing a phone dialing, as I mentioned. Suppose without giving pauses, you can able to speak the digits in a continuum one after another. So, that gives you the desired phone number and all, either 8 digit or 10 digit number, or any sequence of digits you can able to do it using you can able to perform a recognition using connected word recognition problem. And here also the problem is the begin end detection. That means where the total speech utterance, the speech utterance begins and where the speech utterance ends. And in between we know that we have the multiple words, and we need to find out the word boundaries also. Suppose there are 5 words that consist of a speech utterance. So, first thing is that you need to find out where this word sequence begins, where the word sequence end, and afterwards the in between word boundaries also we need to locate, right. And the second one is that here the task is that first of all we need to find out how many words are there in the word sequence and what are they. So, by using 2 level DTW we can able to do that, we can able to perform the recognition. And here the complexity it is also very complex problem, even though it has a less number of words. It appears to be like the number of words are only 20 or 30 against to thousands in case of isolated word, but still here if you try to analyze the complexity, it is still huge, because suppose for example, if you have a 5 word sequence, the possible word sequences will be 20 power 5, that we have seen in case of HMM, like here the number of states there, instead here the number of words, that means at each place there is a possibility of 5 words will be there. There will be a possibility of 20 words are present, because there are 20 different words, unique words are there. So, the first word may be one of these 20 words, second may be again one of these 20. Likewise, you have the possible word sequences will be very huge, even though the word sequence length is small. Even though if you have 5 words, the number of possible word sequence length, possible word sequences are 20 power 5. 20 power 5, it is a huge number. So, from that different possible word sequences, we need to pick up the best word sequence, we need to find out the best word sequence, that is the recognition problem here and all. And here also there is no language model, at all, right. That means no contextual, any word will come after any word. So, therefore, there is no grammar, no contextual information. So, this imposes a difficulty in recognizing the problem, right. So, therefore, we need to explore all the word sequences, and from that we need to find out the best one. And here all words are equally important, that means there is no prior knowledge about which word is important or not. So, therefore, we have to consider all words are equally important. So, these are the various issues that need to be encountered when you try to solve the problem of connected word recognition. So, then the third one is known to be continuous speech recognition. So, this is a conventional speech recognition. So, here given a speech signal, we need to find out the sequence of words, and there is no limit of the sequence of the words, and here there is no limit for the number of words also. The number of means number of unique words. It is like a very generic speech recognition system. It means whatever you speak, like it tries to we have to derive the text out of it, or we have to derive the word sequences from it. So, in that case, here in case of continuous speech recognition, it is a very generic standard one. So, therefore, the larger vocabulary, that means all possible words are legal, all possible words of a language, whichever the words are legal to a language, all those words are legal in this case. That means they are permissible, they need to be recognized. So, therefore, the vocabulary size is very huge, right. It is in terms of dictionary, size of a dictionary. Suppose we want to perform a speech recognition for English, it means that the speech recognizer should recognize all possible words of English, right. And here the case is that what is the suitable unit for recognition? What is the suitable unit for recognition? The suitable unit means, suppose here we need to find out the word sequence. So, it means that what is the suitable unit, that means at the acoustic model level, what kind of unit that need to be recognized, right. And there are different types of units, like at a very lower level we have a basic sounds known to be phonemes, and the next level will be the syllable. Syllable is nothing but constitution of like a 2 or 3 or 4 phonemes. We will see that what is meant by syllable. And syllable means it contains a vowel. Vowel should be there, that is known to be syllable. Vowel is the nucleus of a syllable, and the consonants may or may not exist around it. The consonants may or may not be present, right. So, that is known to be syllable. The vowel is must, and consonants may or may not present and all, right. Right. For example, ka, for example, where we can view that as a syllable. It consists of 2 sounds. One is k followed by a, where a is a vowel and k is a consonant. So, it is a CV, it is a consonant followed by vowel. Likewise, for example, kra, that is k r a, k r a. There are 2 consonants prior to the vowel, that is known to be CCV. So, likewise, we can define the syllable as a vowel is a must, that is vowel is present, and consonants may or may not exist. Consonant may or may not exist. Like for example, a, it is just simply vowel, there is no consonant that is associated to that, right. So, that way it is known to be syllable. And then, so here these phonemes and syllables, these are the units that are closely towards from a speech signal point of view. That means, from the signal you can able to see that based on the signal characteristics, you can able to see that what is the phoneme and what is the syllable characteristics. They are somewhat more reflected from a signal perspective, and whereas the word, phrase and sentence, they are more towards the language perspective. Here, out of these, which of the units are more suitable for recognition? That means, in case of acoustic, if you want to perform acoustic model, so which unit will be used as a recognition unit, as a suitable recognition unit, whether it is a phoneme or a syllable or a word or phrase or sentence. And next one, in continuous speech recognition, contextual information is present. This means that continuous speech means whatever you are speaking in English, it means that whatever the words you are producing, so those words should follow a sequence, should follow a legal sequence of words that forms a sentence or that forms a proper phrase. So, therefore, here in case of continuous speech, we have a contextual information that is present. So, that way one can able to exploit this feature or this information. With that, we can able to, like, even though the acoustic model may introduce some errors or mistakes also, it can be overcome or it can be taken care by using a language model, by knowing a contextual information. And here also again a similar problem like connected word recognition, begin and detection, right, the beginning of a speech utterance and ending of a speech utterance, and in between what are the word boundaries, those are also not known. So, they are also has to be detected. And here all words are not important, because here whatever you are speaking, so we are speaking in view of certain language. So, by knowing a language, even though if you do some errors, if you make some errors in recognizing the words, but still you can able to make out the message, overall message. It means that suppose when in a sentence, suppose one or two words, even though the speech recognizer may be done some mistake, and with that also when you read the whole sentence, if one or two words are erroneous, still we can able to make out the message, right. So, that what it means is that all words are not important. If there is some content word is missed out or wrong, then we lost the whole message itself. But otherwise, if there are some words are missing or not missing, if some words are like erroneously detected, still you can able to make out the message. So, that way even though the word errors may be low, but still you can able to manage to understand the critical message. And again, the continuous speech recognition, that depends upon the mode of speech. That means like whether the speech is a read speech, or whether the speech is extempore, or a conversational, or spontaneous. So, that means here if you look at here, there are the different modes of speech. Read speech means, you can say, take the example as a news reader's speech, like in a television broadcast or any news channel, the way the news reader speaks, that can be viewed as a read speech, because there is some display will be there, and then he has to see the text and he has to read out, and he has to be constrained one way that he has to read out only the text that is present over there, right. And in case of extempore speech, is known to be like kind of lecture mode speech, or like the speakers speaking in a on a platform, like a politicians in a public platforms, whatever they speak. So, they do not see any, there will not be any message, or there will not be any paper which they read and all. So, whatever that comes to their mind, they will speak out. That is not to be extempore speech. And a conversational speech means, actually here when you are speaking to a human, like that based on that, whatever the speech that is generated, is not to be conversational speech. That depends upon who is the target or the other end, whether it is in between the teacher and a student, or is it in between the two friends, or in between two family members. That way the conversational speech also varies from based on the people that are involved in the conversation. Then the spontaneous mode, right. So, these are the various modes of speech, and again when you are building a speech recognition system, so again you need to be take care about what is the specific mode, and accordingly you have to like use some certain constraints, so that the performance can be improved. So, these are the various issues that are involved in the continuous speech recognition. And coming to the basic issues in the engineering for a speech recognition system, to build a speech recognition system will be like, first of all, the very first thing that need to be bothered will be the speech unit for recognition. So, as I mentioned that, so the goal of a speech recognition will be, given a speech signal, you need to derive the text, it is nothing but sequence of words. So, and the possible sound units or possible units for recognition will be, at a very one extreme you have a phonemes, right, and at other extreme you have a sentence level, sentences and all. So, if you choose the phonemes, the number of phonemes will be less, it is about 40 to 50 in any language. That means, whatever the text you take, or whatever the speech you take, or right, in a given language, the number of basic sounds will be only 40 to 50, right. So, that way if we choose the unit the speech unit for recognition as a phoneme, then the number of classes will be limited. So, therefore, not much training huge training data is not required, because it is a only 40 class problem, and for each unit, if you take suppose 1 hour or 2 or 5 hours of speech, proper balanced speech, like, so that all units will come in a uniform way, or uniform distribution manner. So, in that case, like all units are available with equal number, so that you can able to build a model. So, the building a system is easier if you choose a smaller unit, but the problem is that with the smaller unit, right, there is lot of variability will be there, like for example, when you try to in a speech signal, when you try to determine the boundaries of phonemes or sound units, it is very hard. Sometimes you can able to perceive a particular phoneme in the speech, but when you try to figure it out, when you try to mark that particular portion from a speech signal, it is very hard, because it appears to be like the characteristics are embedded in the preceding and following unit, and when you try to mark the boundaries of a particular sound, it is very hard to mark the boundaries. Suppose you mark it, and if you try to listen to that particular like marked portion, you do not feel like the phoneme that you have marked for. So, that way, because it has a variability, means the particular phoneme characteristics that depends upon its previous and following, because here all the sound units are produced by vocal tract system. So, therefore, in a continuum, and the sound units will be uttered like one after another. So, therefore, for a given phoneme, the shape of the vocal tract system, that is highly variable, that depends upon what is the previous sound unit that is uttered and what is the following units that need to be uttered. So, based on that, the corresponding phoneme, the vocal tract shape of the corresponding phoneme will be varied and all. So, that way, even though it is a very small unit, it has a lot of variability. So, that way it is difficult to recognize, or the recognition accuracy will be very vulnerable because of the variability and all. And whereas, if you go for higher units, like as I mentioned, like a word level, where already there are like it is a sequence of phonemes. So, therefore, if you want to utter the particular word, it is a relatively larger in the duration, and any of the speaker and all, he has to utter with the same sequence of sound units by speaking all the sound units in a proper sequence. So, therefore, the variability with respect to the larger units will be less compared to very smaller units and all. So, that is the problem with the smaller units versus the larger units. But coming to the larger units, the variability may be less, but the number of units will be very huge in number. Suppose if you take a word, as I mentioned, that the number of words, possible words in a language will be order of 10 power 5 and 10 power 6, that is the order, like lakhs, right. And building the word models like is very tough, because so many models and your classification system has to discriminate across all the words. So, a lot of training data is required. Not only that, as the number of classes increases, the discrimination power of a classification system also very hard to discriminate. So, that way there are issues with the smaller units, as well there are units with the larger units also. And the speech recognition system, that depends upon the task syntax, as I mentioned, like associated with the grammar. Like as I mentioned, suppose if the task is isolated word recognition, then there is no grammar is involved, and if the task consists of connected word recognition, we know that the number of words are limited, very less in number, but the sequence of words are expected, right. And if it is a continuous word recognition, if a continuous speech recognition, then there is a syntax that is involved, because the sequence of words that follow the grammar or the syntax of a particular language. So, we can exploit that constraint. So, with that we can able to perform the task with more efficiently. And similarly, task perplexity. So, task perplexity means it indicates the average word branching factor. It means that, suppose as I mentioned, that in case of continuous speech recognition, we need to predict the word sequence. It means that we have a word 1, then word 2, then word 3, word 4, and so on. So, when you are speaking the words in a sentence, the first word has lot of possibilities will be there. That means any word can happen to be a first word, and once you pick up the first word, once you just decide the first word, following that word, the number of words that occurred after this word will be reduced, right. And then after you utter the second word, then for uttering the third word, the number of words that are that happens to be a third word will be still less compared to the second word. So, that way here the average, the perplexity, task perplexity is nothing but average word branching factor. So, that way for different word sequences, if you try to analyze what is the branching factor with respect to the after each word, right. So, then if you take an average of what, and then if you try to analyze for different word sequences, what are the word perplexability. So, that way we can able to analyze the complexity of the task also. And also the speech recognition also depends upon the speaking mode, right. That means whether you are speaking, whether it is an isolated word or connected word or continuous or spontaneous, that we have discussed. And similarly, the speaker, it also depends upon the speaker, because as I mentioned, the speech signal also carries the speaker specific information, right. So, therefore, if you want to build the speech recognition which is specific to a speaker, right, or it is a speaker independent, or it is a speaker adaptive. So, it means a speaker specific means, for example, if you want to interact with your mobile, for example, then the speech recognition that is required to access your mobile, that can be speaker specific, because your mobile and you are the only person that need to access your mobile. So, therefore, if you want to design, if you want to have a voice interface for your mobile, then that speech recognition that will be carried out on this mobile can be speaker specific, and speaker independent means it is like generic applications. For a generic application, suppose we have like a generic system which is in a corporate organization or enterprise, and where it provides a voice interface, several people used to interact with that. So, in that case, the machine should recognize any speaker's voice, the machine should derive the text from any speaker's voice. So, that way the speech recognition system that need to be developed in that context will be speaker independent. And a speaker adaptive, it means that actually here you have a system, first it is initially built with which is like for a particular speaker, and afterwards it can be adaptable to other speakers also. That means by giving some speech samples of a for a new speaker, then with that actually again a model will be refined with respect to that particular speaker, and it will be adapting. And likewise with whom your interaction with the machine or with the corresponding machine with the human. And the speaker environment also, whether the speaker is is uttering in the indoor environment or outdoor or crowded places. So, therefore, the environment is also matters. Otherwise, suppose we build a system with the speech corresponds to indoor, and then afterwards when you try to test the system where you record the speech from a crowded places and outdoors, then you have a problem, right. And then the effective transducer, like that is also, suppose the speech that is used for building the system will be with one microphone, and afterwards when you want to test that model using, for example, with your laptop microphone, with a laptop interface for example, then there will be a mismatch, because the speech that is used for building the models are trained with the microphone which have the different characteristics, and when you are testing with the different some other thing where you have issues will be there. And the transmission channel also the same thing. That means when you want to test the system through a telephonic channel for example, then the telephonic channel will introduce some distortion into the signal, and because of that the features whatever is extracted from that will be deviated from the features that are used for building the model and all. So, that way again we have issues. And inherent speech variability, that means here as we know that the speech signal has certain variability, and because of that there is some legal permissible variations or has to be taken care. So, even though if you speak the same person is speaking the same utterance multiple times, you do not see that any of the two utterances are very similar or very close or are exactly same and all. There will be some tolerance or there will be some certain legal variation that is permissible, and that is the beauty of the speech. Because of that you will feel a naturalness, otherwise you will feel monotonous, right. So, therefore, the speech inherent variability will be there. So, all these things has to be taken care when you are building the speech recognition system and all. Yeah, the next part here is that as I mentioned that earlier, we have a language model. Here the language model means we need to determine the given word sequence from the available statistical information. That means as a English language, so we know that in a normal conversation, normal speech, so certain words are very frequently used and certain sequence of words are very frequently used compared to some other sequence of words. So, in that context here, after you derive the sequence of sounds, from the sequence of sounds we need to derive the words, and then from the words you need to derive the sequence of words. So, in that context we use the language model to validate that. So, here here we are giving the formulation for a language model, and here suppose the word sequence W equals to, suppose these are the word sequence W1, W2, these are sequence of words. If you want to find out the probability of this word sequence in the language model, so what we need to do is that we need to estimate this. We need to estimate, we can compute the probability of word sequence. If you want to compute that, so we need to compute all these conditional probabilities. That means here the word sequence is W1 is the first one, and afterwards the next word is W2, next word is W, and the last word to be uttered is WQ. If you want to find out what is the probability of this word sequence, happens to be the initial word is W1, next word is W2 and the final word is WQ will be, you need to estimate this probability by computing all these conditional probability and taking a product of that, it will give you the probability of this word sequence. That is the probability of W1 is the first word, that is a no preceding history, and when you are speaking to W2, W1 has to be followed. So, therefore, probability of W2 given the W1 and similarly probability of W3 given the W1 W2. So, likewise you need to compute all these conditional probabilities and then you need to multiply and you will get the probability of word sequence. So, that way you can able to compute the probability of word sequence, but here computing the history of a particular word with respect to long history is very tough. So, therefore, we introduced the approach known to be n-gram model, where in case of n-gram model where we consider the history only up to n preceding words, that means if you want to find out the probability of Wj given, like we need to see that n preceding words like starting from W1, W2 up to this is the way we have to compute, but this is approximated by Wj by n preceding words, Wj minus 1 to n preceding words, that is all. And now here by choosing this n we have different models. If n equals to 1 is known to be unigram model, it means that here we are not considering any history itself, it means no context at all, like this is suitable for a word isolated word recognition, that means there is no context at all, only one word is possible and any word can come. So, this is the probability of Wj, there is no context at all. And bigram model means here probability of a word given its preceding word. So, we had to compute the possibility, that means if we want to compute probability of Wj through bigram model means we have to see that probability of Wj given the other word. We have several other words are possible. So, we need to find out all those possible words and take the average of that gives you the bigram probability. Likewise, the trigram, the probability of Wj given Wj minus 1 and Wj minus 2. So, here there are different possibilities are there, because Wj minus 1 can take several words and Wj minus 2 can take several words and Wj can take several words. So, then we have to see that what is the probability of this particular thing, this is known to be a trigram model. So, likewise, but usually in the language model it is very difficult to compute the n-gram model for a larger values of n. If you see that with the trigram model itself, if you see that for computing a probability of a given word by taking the two other words, right, and these two other words will take again possibility of taking the several words. So, therefore, there are lots of possibilities and computing all of them will be very computationally involved, and not only that you have a lot of training data is required, huge amount of training corpus is required to estimate these probabilities. So, that way these are the different models where by considering different amount of history, and then the word pair models is known to be what is the probability of a word followed by some other word, and if this word pair is existing then it equals to 1, probability equals to 1, if the word pair does not exist it is 0. So, that way instead of using this bigram and trigram model, so we can use the word pair models, and with that just checking that what is the possibility of getting this word followed by this particular word. So, that way we can able to do it, and in this case by using this we can estimate the probability. And if there is no grammar model means it means that the probability of a word followed by some other word is 1 for all possibilities of j and k. That means any word can follow any other word, any word can follow any other word. So, therefore, the no grammar means it is always 1. In case of a grammar, the word pair models means if a grammar is involved means there is certain pairs are valid, some pairs are not valid, right. So, no grammar means like it is always 1, that means all possibilities has to be considered and all. So, in case of statistical language model, how do you estimate this n-gram probabilities means this is the way you can able to, that means for the given word sequence W1, W2 up to WQ, if you want to estimate the n-gram probability. So, this is the formulation we have to estimate, that means probability of Wi where I equals to 1 to q, because all these conditional probabilities have to be estimate. So, for each of them just take that I equals to 1 to q will give you each of them, right, and then we have to compute this one probability of Wi given this history of n grams. And how do you compute this one? This is nothing but by using statistically you can able to estimate this probability like this, but it is nothing but the possibility of occurrences of W1 followed by Wi minus Wi followed by I minus 1, I minus 2, I minus n plus 1 by I minus 1, I minus 2. That means, here if you look at these numerator denominator, numerator contains one additional word Wi following the history, there are n words, whereas the denominator contains only the previous n words. So, therefore, obviously, the denominator contains the more number of possibilities, because we are adding the when you are increasing the sequence length, it means the number of possibilities will be reduced, number of possible occurrences will be reduced. So, that way by using these you can able to estimate the probability, statistically you can able to estimate the probability of the n-gram models and all. So, this way you can able to estimate the probability of n-gram models, right. So, in the next class we will try to discuss about the template matching, how do you perform a template matching using dynamic time warping. This we can do it in the next class, and now we will stop here. Thank you.